and welcome to lesson 3 of JavaScript. In this lesson, we are going to look at functions in JavaScript. My name is Mildred. In the last lesson, we looked at how to create variables in JavaScript, and we said that variable names are case sensitive. We also said that when we create variables, we can use any name as the identifier. The name can contain letters, can contain the underscore sign, the dollar sign, can contain numbers, but it must not begin with a number. So if we want to write, for instance, I want to create a variable called first name. I can use an underscore, I can use a dollar sign, I can create a name, but I must not begin this name with a number. Or I can use an underscore to start or a dollar sign to start. Also, we looked at the different types of operators we have for the different operations that we can perform: arithmetic operation, assignment, logical operator. In this lesson, we want to look at the data type of the values that we assign to variables. We want to look at how to create functions in JavaScript. Now, when we have a number, this is a number data type. The number can be a whole number or a decimal number in JavaScript. We have something we call strings. Let's say my first name. I want to put my first name here. A string in JavaScript is written within single or double quotes. So I can use single quotes or I can use double quotes to write the value that is a string. So any word, character, sentence is a string in JavaScript. We also have variables that can collect several values. We have arrays, which is created with a square bracket like this, and we can list several values for this. Let's say I want to have an array of first name. I can list them like this. All of my strings will be quoted and all of my numbers can just remain unquoted. If you quote a number, it becomes a string. We also have something called object that uses curly bracket like this, and within the curly bracket you write your values as a key value pair. So let's say I want to write first name like this, and I'll put my first name here is the colon Mildred. I will have last name, and so this is how we create objects. So we are going to look at objects and arrays in details later on, but this is how we use the different data types in JavaScript. Let us look at how to create functions. I am going to create a new file, and I'm going to call this file functions.js. On my index page here, or my introduction.html file, I will put a link to the functions file that I have just created. To create a function in JavaScript, you start with the keyword function. Now also, know that when you are creating variables, you cannot use keywords. JavaScript keywords has a name for your variable, and keywords are things with special meaning in JavaScript. Things like function is a keyword, so I cannot name a variable function because it has a special meaning in JavaScript. Things like this. So these are keywords, and we cannot name our variables with JavaScript keywords. So we use a function like this, a name for the function which follows the same convention or the same naming rules as that of a variable. Let's say I want to create a function called addition. I'll put a parenthesis like this, and within this parenthesis I can decide to put parameters or arguments, and these parameters are inputs that goes into the function, and we want this function to do something with the input, and then we put a pair of curly braces like this. It is within the curly brace that we write what the function is going to do. Let's say we want a function that when invoked or when called will add two numbers. So I'm going to supply two parameters a and b. What I want this function to do when it is called is to return, and so we use a return statement to return something to the user. We are going to return the addition of a and b. That's what we want to return. And so when I call this function, or I send this function as a value of a variable, so when I call this function, and calling the function just means writing the function name and supplying parameters, let's say 2, 3, like this, and this is going to add 2 and 3 to give us 5. So let's look at our introduction here. I want this to be passed into this p tag with the id of function, and so I'm going to come here and say document dot get element by id. I want it to give me the sum of 2 and 3. So my addition function is going to add 2 and 3, and when I go to my web page, I will have 5 printed out on the web page. If I change what this is, let's say we want 10 and 10, save and refresh, I will have 20 printed out on the page. So this is basically how we create functions. We are going to look at complex ways of creating functions, nested functions, or calling another function within a function as we go on. But function is something we write to keep our program maintainable and organized, and we can reuse a particular piece of code over and over again, so it makes our code maintainable. And so if you have like a web application and you use object-oriented programming pattern, for instance, you have all of your methods and all of your functions written. and you need to make changes to functionalities, you only need to change the function and it applies to the site, and you can reuse those functions even outside of your application to perform the same type of functionality. So let's say you are creating a calculator, for instance. You have a function that when the addition button is clicked, it adds the numbers that are passed in as a parameter. You can also create something for multiplication that returns the multiplication of the parameters passed in. You can also have more complex functions, like let's say we want to create a function that calculates the area of a circle, for instance. So let's say function area circle. Now we know that the formula for the area of a circle is pi r squared. We want this function to collect just one parameter. So let's say we are creating a function that, given the diameter of a circle, calculates the area of the circle. So let's say it takes a parameter called x. We want to declare a variable here and say let diameter be equal to x. We also want to say let radius be equal to diameter over 2. Now you know that this is redundant. We can decide not to actually let diameter be equal to x, but we can decide to say let radius be equal to x over 2 and skip the diameter part. So you can make your code shorter and remove what is unnecessary and what makes the code still function. So some of your assignments or some of your quizzes will have codes for you to reduce the number of lines of code, remove what is not necessary, and what will make the code still function as it is supposed to without having some particular lines of code in them. So let's reduce the diameter over 2, and then we'll say we want to have pi to be equal to 3.14, or let's say constant pi is equal to 3.14, and then we also want to say let area be equal to pi times radius raised to the power of 2, and then we want to return area. So now we've created a function that, when called, will always calculate the area of a circle given the diameter of the circle. And so let's say we want to call this, and we'll say area circle, and we have a diameter of 20, for instance. When I save this and I refresh my page, it is going to calculate the area of the circle whose diameter is 20. If I change the diameter of the circle, for instance, to be 14, save, and I'll have the area recalculated. So this is how we create functions that do something in particular, and every time we want to do something, we can reuse the same function by calling the function. Calling the function means writing the function name with the parentheses and supplying the arguments that it needs. Sometimes you have functions that do not contain arguments and do not return anything to the user. Maybe you have a function like timeout function that checks the time that the last mouse movement. If it is idle, you want to log out the user. If the mouse has moved, then you want to recalculate the timeout. You want to set a particular timeout duration. So there are functions that do not take parameter, do not return anything to the user, but does something on the system. And so as we go deeper into object-oriented programming, we are going to look at the different ways of writing functions and the different uses of function. We are going to look at the complexities of creating functions and nesting functions. So this is where we end this lesson. Thank you, and see you in the next lesson.